Hey folks, you're listening to the Java Easily podcast, episode number 20. Java Easy. News, tutorials, tips. Everything you need to know as a beginner Java developer. Hey again, welcome back to the podcast. Now, just before we get started, if you're completely new to Java, you might want to check out our Java Beginner's Starter Guide. It's available at javaeasily.com, so you can go grab it there. It's a super helpful guide. It's going to get you up and running with Java really quickly, and it's completely free. It's just a really good resource for absolute beginners to get started with Java programming. But anyway, on with the episode. Okay, so in the last few episodes, we've been talking about the different knowledge levels that people can go through when getting to grips with objects in Java. And in this episode today, we're going to continue in this mini-series. A quick review of the levels first, though, just so we know we're on the same page. In my opinion, there are roughly 4 levels that you go through in terms of your knowledge and experience level and just general kind of exposure to the concepts when you're learning about and coding with objects in Java. That is, doing object-oriented programming. So the first level really is about syntax. So ultimately, as a Java beginner, you have to be able to master the syntax, that is the specific keywords that we have, to be able to do the base level things. And those would be, for example, creating classes with the class keyword, understanding the different modifiers, so public and private in the first instance, which you typically declare methods with on that class and data members with on that class too. And so once you're in the position where you can actually define a class, in other words, you understand the syntax to define classes, then we really kind of ascend to level 2. And level 2 is all about the foundations of OO. So this is where we're looking at encapsulation, inheritance, and polymorphism. And specifically this level, now that we've started out with a good base knowledge of the syntax, when we get to this level 2, this OO foundations kind of level, where we're looking at things like encapsulation, inheritance, and polymorphism, it's really then about understanding how that syntax is applied to be able to code up these different foundational OO concepts. So for example, in the last episode, we looked at encapsulation, also known as information hiding, and the skill there, as a beginner, is about being able to separate the public API that you offer to calling clients through writing methods which are annotated with this public keyword, so to give them public visibility. But also it's about preserving the integrity of the state of the object by ensuring that its internals are kept private, that is, not open to anybody outside the class. And we do that with the private keyword, which applies this so-called private visibility level to those data members. So that was encapsulation. So you can see how understanding the syntax is helping us being able to facilitate producing that kind of idea, that kind of OO foundational idea of encapsulation. Then we looked at inheritance in last week's episode. And again, it's about syntax, but also about visibility as well, because now we're introducing the extends keyword, which is how we extend so-called superclasses to come up with new subclasses. And that even conceptually is something to get your head around. The fact that superclasses are more general in nature and subclasses are more specialized. So you have to get your head around things like that as well. So now with inheritance, it's kind of mastering not only syntax, but also the conceptual side of it as well, about this notion of superclasses and subclasses, and in the more advanced case, class hierarchies as well. The next foundational concept is then polymorphism, which we're going to see in this episode in a few moments. But the key point is, at level 2, it's really about these OO foundational building blocks, and about having the confidence to be able to use the syntax that Java gives you to be able to create these foundational structures, these relationships between the classes that are provided by these concepts as we code up our application. And it's about really having confidence with these and getting comfortable in how they work. Now, once we've got that under our belt, we kind of get to level 3. Level 3 is really about getting so comfortable with how these different OO foundational concepts work together that we almost do these things on autopilot. In other words, we don't spend time actually thinking about, okay, do I need to use encapsulation here? Or, is this going to be a case of polymorphism here or what have you? It's not like that, because at this level, at level 3, you're so familiar with these foundational OO constructs that you can just start creating domain models, that is, classes which actually model the real world, without thinking too much about the actual mechanics of it at the Java language level itself. It's a bit like learning to drive a car at first, when in the beginning you have all these different things to check and to do and to coordinate. So which feet are doing what on which pedals, doing all-round observations, looking in the mirrors, even before then adjusting your seatbelt, checking the mirror, putting a turning signal on or indicator on to say that you're about to pull away, all that kind of stuff. But once you've been driving for a while, you don't even think about these things. When I get into my car now, for example, I can be aware within, say, 3 to 5 seconds. Of course, I do it safely, by the way, of course. But just figuratively speaking, I no longer have to be cognizant or conscious of the lower level things, which it took me ages to master, as it does for anybody who's learning to drive from the outset, because now we're kind of on autopilot and we can just go driving. And similarly, at level 3, we've now mastered these OO foundational constructs. And so because these are now so automatic, just like in the driving case, we can now just go coding, that kind of thing. So it's that kind of idea. Now, once you've been at level 3 for a while, you're going to become so expert in being able to use these constructs that you start to see deficiencies in the code that you're writing, and you start to be able to see areas for improvement. And sometimes it's possible that you can come up with a solution to these design deficiencies that you see in the code on your own, just based on having this good foundational knowledge of the syntax and OO concepts that you've now got from level 3. But what will probably happen instead is that you'll start reading more and more about object-oriented design and object-oriented software engineering, and at that point you'll come across design patterns, which we're going to talk about in next week's episode. But in a nutshell, design patterns are basically pre-canned arrangements of classes, arrangements of classes in terms of how they relate to each other and the mechanics of how they interact with each other. They're kind of pre-canned, almost templates, if you like, mental templates at least, that we can apply to our own code, to our own objects, to our own classes that we've written, to be able to solve these design issues that we'll now have come to notice at level 3. And that's what level 4 is all about. It's all about design patterns. So to recap, level 1 is about syntax, getting comfortable with being able to define classes and use the various keywords at a very, very base level. Level 2 is about the OO foundations, understanding these OO foundational concepts of encapsulation, inheritance, and polymorphism, and understand how these concepts are coded up using that syntax and how they interact and what the ideas are behind them. Level 3 is basically about becoming so comfortable with how those constructs work, these OO foundational constructs, that we can just code away almost on autopilot, not really thinking about the mechanics of the syntax that we're writing and that kind of thing. And we, at that point, are just purely focused on and working at the abstraction level of considering our domain model. That is, just coding up the things that model our real world, real life objects, without thinking of the mechanics of what's happening underneath in terms of encapsulation, inheritance, and polymorphism and that kind of thing. And then finally we jump up to level 4, which is about getting a solid understanding of design patterns and then being able to work with those confidently so that we can apply the very best design solutions that are out there to the existing code base that we're working with or that we're evolving. And at that point, you're off to the races, you're a fully fledged, paid up member of being an object-oriented developer in Java, and it's a good place to be at. So to return back to this week's episode, this week we're talking about polymorphism, and that's the third foundational construct in this whole coding with objects thing that we need to get familiar with. It's also, as well, by the way, probably the most complex of the three concepts. So it starts off with encapsulation being a fairly simple idea to comprehend, inheritance being a little bit more abstract and involving a little bit more syntax, and then we move on to polymorphism, which probably just stretches your mental abilities just that little bit further in the beginning. But stay with me, hopefully it'll become clear and we can see what its purpose is, why it's there, how we can use it, and why it's a really cool feature in not just Java, but in object-oriented programming languages in general. So polymorphism, the word comes from the Greek poly, which means many, and morph, which means forms. So overall, polymorphism means many forms. And the reasoning behind this, I guess, is the fact that a particular class, or if we're being more specific here, a particular interface, an interface, if you recall, is effectively a class in Java, so it's a type in Java, which doesn't have any implementation associated with it, or any state either. So an interface just defines what we know as the contract for a class or a set of classes, and this contract being the methods, these abstract methods that are defined on the interface, that any class that implements that interface is obliged to provide an implementation for. So for example, suppose we have an interface called dog. Okay, so an interface of a type which is called dog. And we kind of touched upon this last week slightly. Maybe the dog has two methods on it. Maybe it has a method bark and it has a method eat, because that's the two things that dogs can do. Now in this interface dog, which has these two methods, bark and eat, there's no implementation. So you can't call the method on this interface, or more specifically, you can't even create an instance of this interface because it's not a class, it's an interface. And we can't instantiate interfaces because there's nothing to instantiate. You can only instantiate, that is, create a new object of, a new instance of, a type in Java if it's a class. And moreover, if it's a class that isn't abstract or it isn't an interface. So that means we have an interface dog with these two methods. And the point of this interface is really that it's defining what it means to be a dog in our application. So if we've coded the application such that it's important, for example, that a dog can bark and a dog can eat, obviously it's a contrived example. You don't normally code up dogs in Java applications. But if it's necessary to have a concept of a dog, and we've deemed it necessary for it to have two methods, bark and eat, that means that whenever we create so-called concrete classes of dog, that is by specifying a class that implements the dog interface, then at that point then, we're obliged to provide an implementation of those two methods. For example, we might create a class poodle, where the class poodle implements the dog interface. So class poodle implements dog. And then when we start to write that, the IDE will show us an error and we'll say, you know what, you need to implement these methods, which come in from the dog interface, which are bark and eat. And then we just type out the implementation for those methods. In other words, what we want them to do. And for the sake of example, we could just print out woof woof for the bark method and gobble 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 for the eat method. Although that's probably more to do with turkeys than Thanksgiving, but if we forget about that for a second. At this point, we have a poodle, which is instantiable. That is, we can create a new instance of it because it's a proper class. It's a so-called concrete class, which means that we can create a new instance of it on the heap using the new keyword with the syntax new poodle. And we could also do the same thing again. You know, we might deem it necessary that at some point later in the application's development, we've now got to support the notion of bulldogs and not just poodles. So again, we could create a class bulldog, which implements dog, And again, we'd have to give implementations for the bark and eat methods, just like we did in the poodle class. So in the bulldog case, we might print out woof, woof, woof in capitals to kind of indicate that it's a louder bark, I guess, than a poodle. And for the eat method, I don't know, we could just print something like gobble slurp, or whatever it might be. The key point being is that these two concrete classes now, poodle and bulldog, both have what's known as the same supertype, which is the interface dog, that they both implement. Now, okay, you're saying that's kind of cool, but why is it interesting and why is it important? Or why is it useful? Well, it's useful because in Java we're allowed to refer to an object by its supertype. And so what I mean by that is that you have an option, right? When you're creating a poodle or you're creating a bulldog, you have an option of what the variable type is going to be that you hold a reference to that object in. So for example, you could do poodle Valentina equals new poodle to create a poodle named Valentina. And you could also do bulldog Romeo equals new bulldog. I don't know where I'm pulling these names from, by the way, but anyway, just stay with me. You could do, poodle Valentino equals new poodle, bulldog Romeo equals new bulldog, and you could hold references to objects of these classes in that way. That's fine. But what Java also allows you to do with the statement I just made about having references to the supertype is that you can make the variable that holds this reference, instead of it being bulldog or instead of it being poodle, you can make it be the interface type. So in other words, you could do dog Valentino equals new poodle, or you could do dog Romeo equals new bulldog. Now you're probably already familiar with this. If you've done a bit more Java than just very, very, very basic stuff, you've probably come across the collections classes in the java.util package. And if you've done so, you'll have come across this kind of programming idiom where we'll use lists, for example, by declaring a reference type of type list whenever we get an instance of a linked list or an array list. So to make that more concrete, typically you might do, for example, list mylist equals new linked list, or list mylist equals new array list. Now what's cool about this is the fact that because we hold the variable in terms of its supertype, when I say supertype, by the way, I mean that it's just a type that's kind of higher up in the class hierarchy, which is probably too advanced a way to express it. So to put it a different way or a simpler way, a supertype means that it's either the interface that the class is implementing or it's a superclass type. Now because you can pass this supertype in place of the actual concrete types, in other words, because we can pass in list to, for example, a collections utility method, as opposed to passing in a linked list or an array list. I mean, don't get me wrong, we'll still pass in physically at runtime. It'll either be physically an instance of an array list or physically an instance of a linked list. But the fact is, because the method in that collection class might be defined that it takes a parameter of type list, so in other words, not of type linked list or of type array list, because it's declaring a parameter of type list, which is the supertype, it means, and this is the cool part, that we can pass in a linked list if we want to, or we can pass in an array list if we want to. Similarly, to go back to our dog example, we could write a method that just takes something of dog type, but our code behind the scenes will still be able to invoke the bark method, it'll still be able to invoke the eat method, because they're defined on the supertype, on the dog interface, but we didn't have to bind the type of that parameter to the concrete class that we were passing in. In other words, we didn't have to say that the method takes a poodle, or say that the method takes a bulldog. We can just say, no, it takes a parameter of this supertype. And this means that that method, when we invoke internally inside that method, the bark or the eat method, doesn't have to know what specific type we passed in. It just knows it's working with something which happens to be some kind of dog. And the fact that we can give different implementations of the methods on this supertype, remember we gave a different implementation of the bark methods. We did woof woof for poodle, woof woof in caps or whatever it was for bulldog, and we did a similar thing for eat. Because of this is what polymorphism is. It's the ability for a specific type, in this case the dog type, which is the interface type, to present itself or to be able to behave in different ways, hence this polymorphism idea, polymorph, many forms. Dog now has many forms, it can be a poodle form or it can be a bulldog form, and this is what polymorphism is all about. Now, when I first discovered this, probably maybe about 17, 18 years ago, I can't quite remember exactly when it was, but when I first discovered this idea that you could not just hold references to subclasses in terms of their superclass type or their supertype. When I first discovered that you can pass it in at the method level as well by having a parameter of the supertype, I was absolutely blown away by this in Java at the time, because I just found it a really elegant way of being able to code. Because the nice thing about this, and it's very subtle, but it's really, really, really cool, absolutely awesome. The nice thing about this, if you think about it, is you kind of future-proof your code. You're almost writing code which is guaranteed to work in the future, with types that haven't even been written yet. So for example, when I release this dog application or whatever it is, maybe I've got a method in there which processes a list of dogs. So it takes a list of dog, and in this collection, in this list, I might have bulldogs, I might have poodles, but but my list processing method is just calling bark and eat or whatever. And then polymorphically, the correct, more specific implementation is being called at runtime through a process called dynamic dispatch. If you want to have a read up on that, that's the technical term for it. So that might be one aspect of my program where I'm processing this list of different types of dogs. I also might have a method as well, which takes a parameter of type dog and it does something there as well based on whatever I've defined in the interface of the dog type. But let's say I just released that program, so I released that application out into the wild. And then for the second release of the program, some requirements come in that we now need to deal with Schnauzer dogs, for example. Well, no problem. All we've got to do is create a new implementation of dog. So class Schnauzer implements dog and implement these two methods, bark and eat. And that means that our program now, without any additional coding to the list processing method or to the method which takes a dog, without even touching that, right? It can now happily work with this other type of dog that was effectively written in the future with respect to when I originally wrote the code, because the requirements hadn't come in at that stage that we actually wanted to deal with this particular type of dog. And that's the power of polymorphism. Really cool feature, an absolute cornerstone of object-oriented design and object-oriented programming in general. And that's really the final cornerstone of these OO foundational concepts that we're looking at level 1, that we've been looking at over the past 2 episodes as well. So yeah, encapsulation, inheritance, polymorphism, those are the 3 cornerstones of OO. Now in next week's episode, we're going to look at design patterns, which is going to be an exciting episode, so stay tuned for that. And in the meantime, all that remains to say is have a great day ahead. Hope you've enjoyed this episode. Keep enjoying your coding journey and speak soon. Bye.